So we trace the central angle AOC. And it is central because it's connected to the center. Yes, ma'am. If you see controlled chaos, it's 3C. Okay? And sing it with me. Measure of a central angle to its arc the same. So right here, if this is 60, this out here is 60. You are correct. All right, so our central angle here is 60 degrees. Now our inscribed angle, see B, darken B, write the word on. That's going to be really important today. The arms of the angle. Arm in. You see what I mean by arm in? It's inside. Arms in. And I'm sorry to make you actually have to draw, but I want you to think about a hand. Make yourself a little pretend hand there. I'm trying to think which way thumbs go. Those are hands. Okay, just write the word grab. So we're going to visualize this together in just a moment. Yeah, little stick figure hands, or, you know, the 3-finger Mickey Mouse hands. All right, so you visualize this. Take your hands, make it straight. Okay, so imagine this is a piece of the circle. Pop it on your head. Say vertex on. So that's, see that red? That's what you're visualizing right now. So the vertex of the angle is on the circle. Say vertex on. Say arms in, hands grab. Now when I say grab, it's grabbing a piece of the arc. Can you visualize that? So here, what degrees are we grabbing? 60. So head on, arms in, hands grab. I grab 60. Now draw your hands back to your chest so the angle has to measure what?
30.
No?
30.
Yeah, measure of a central angle to its arc the same. The smaller angle of inscribed is half the arc. Its plane. It's part of the new song. Okay? So it's a measure of a central angle to its arc the same. Smaller angle of inscribed is half the arc. Its plane. So that's right back here is 30 degrees. Okay? This is an inscribed angle. Huh? Plane. Did I spell plane wrong? No. Plane. All right. Go to your reference booklet. Let's summarize this in your reference booklet. Okay, so we learned last class that the angle equals the arc. Okay, and because that's a central angle, whoops, that's inscribed. Hang on, I'm putting that in the wrong place. Excuse me. Okay, whoops, I didn't realize I was shifted. Okay, here we go. This you should already have. We have a central angle like this, and that angle is equal to that arc out here. Okay, song goes. Measure of a central angle to its arc the same. Sing it with me. Measure of a central angle to its arc the same. Now, what's really nice, how many angles are we, show me with fingers, how many angles are we ultimately learning? How many angles? 7. Okay, guess what? You are not memorizing 7 distinct equations, because if the vertex is in the same position, it's the same equation. In an inscribed angle, the vertex is on the circle. In a tan chord, the vertex is on the circle. If the vertex is in the same position, on and on, you're going to have the exact same equation. That's helpful because honestly, you only have 4 equations to memorize. So an inscribed angle looks like so. All right, so we're going to inscribe arms in. There's my hands grab. So angle equals, and it's going to be this time half the arc. That's last night's videos. Half the arc. Same position, same equation. Say it. Same position, same equation. Now a tan chord is exactly what its mate talked about. A tangent is where it just touches. So you draw a straight line right through that dot. Straight line right through that dot. That's a tangent. And then we have a chord, which from there, and then a segment whose endpoints are on the circle. So that's a chord. That's why this angle here, that's why that's called a tan chord. So you need to visualize it. So technically, you put one arm out, you have one arm in the circle, and then your other arm just kind of touches the circle. Can you visualize that? Okay? You're still grabbing an arc. Can you visualize that? Everybody grab your arc. Okay? So that red angle grabs from here to here. And guess what? It's still half. Because same position, same equation. Same position, same equation. Same position, same equation. I'd like you to add an additional circle right here because there's something I told you last class and you kind of figured out instinctually, but I didn't really tell you why. So try to make a better circle than I did. Okay, ready? Draw yourself a tangent. Darken your point of tangency. There's your tan. Put a dot for the center of the circle. Now, last class, we figured out that all diameters are also chords, right? We figured that out last class. So draw in a diameter, which technically is also a chord. Now, we just learned a tan chord is how much of the arc it's grabbing. Oh, no. Guys, it's what? Out loud? Please repeat accurately. Half, okay? All right, ready? Trace from here to here, please. Trace from here to here. That light blue, how many degrees? Okay, light blue is 180. So what on earth has to be back here? No? It's half. Okay, that's where that 90 came from mathematically. Last class, I just had you kind of trace it, and you all kind of just physically like, oh, that feels like 90, must be 90. Well, that's why. Okay? So here's the rest of the song. We're going to sing it from the top, okay? Because you have to have these memorized. If you don't have these memorized, we're kind of toast. Goes like so. Measure of a central angle to its arc the same. The smaller angle of inscribed is half the arc its plane. A tan chord angle is the same as the one inscribed. Fortunately, we're stopping right in the middle of the sentence. Okay, from the top, one more time. I'll slow it down. Measure of a central angle to its arc the same. The smaller angle of inscribed is half the arc its plane. A tan chord angle is the same as the one inscribed. A chord, yeah, that's as far as we're getting. Chords next class. Alrighty, guys. What I'd like you to do is bounce over, please, in your packet to page 4. Go right now to page 4, please. What's my recording? I thought I hit record. Did I not hit record? There it is. Page 4, guys. Page 4. Someone turn on the lights for me, please. Page 4, please. Thank you.